Hello Internet, my name is Nate, and this is the first in a series of videos about my research and development world in Factorio. This is where I build and test contraptions and concepts. For the most part, these are based on lean manufacturing principles or arbitrary rules or restrictions I set up for myself. So you may find some of these useful in your game, but to use them effectively, you'll usually need a demand-based, just-in-time, pull manufacturing style factory. I'll explain the system that I use for that in an upcoming video, but I wanted to start with one with a kind of a more universally useful concept. So this first one is the demand-based, lean, load-balanced, multifunctional, tileable furnace array. So let's go take a look at that, and I will explain what it does. This is the tileable furnace array, and it works in a couple of modes. Below maximum load, it meets the demand exactly. So if your factory requires 10 of iron plates, it will produce exactly 10 iron plates. And this will make a little bit more sense when I get into the demand video, but consider 10 just to be the amount that a single inserter can do. So this is what 10 inserters could do from a device to a line. The next thing is if we get above the maximum load that it can deal with exactly, it load balances. So it allocates furnaces based on the percentage of load. So it will never stop producing things if they're needed, but if you start pulling a whole lot more through the system than it is capable of producing, it will cut down a little bit on the higher end things and ramp up the lower end ones so they match in the ratio to what they're being requested as. The blueprint for this can easily expand the array. It's tileable. I'll show you that here. So if we, where did I put it? There it is. So the way this works is you basically align it and drop it on, and it connects everything up. And assuming you had construction bots or whatnot to put this together, it would all work. This is how I built the entire thing. The one thing you have to realize is after expanding it, you do need to go in and update the various thresholds for production on these. So each one has a particular number that it is going to activate at, and that number is based on the total number of furnaces you have. So pretty straightforward, but you've got to update that if you do expand the array. All right, let's see. The other thing this does is due to the integer division that Factorio has, this uses much larger numbers than what we're actually looking at for demand in order to get some additional precision. So everything is basically multiplied by 100 when it's doing calculations to give us a couple of decimal places to get just a little bit more precision so we can adapt a little better. All right, so let me show you how this actually works. Again, the demand system will be kind of important to understanding the whole bit of it, but I can show you how this works by kind of inserting demand into the system right here. So let's say I need level 2 of iron plates. So I will say that. So now my first 2 furnaces have lit up. We've got 2 furnaces producing iron plate. That's great. If I had factories needing 2 output of iron plate, that would work. These are also unmodified furnaces, so the production speed on these could be sped up quite a bit using modules. So now if I also decide that I want some copper, let's say I have a demand for 4 copper or 5 copper, you can see now on the other side of the array I have 5 furnaces lit up using copper. And this will continue to meet demand exactly until the sum of your copper and iron demand exceed what the furnace can put out as a whole. So in this case, we have 40 furnaces. So if I increase demand for iron plate to say 30, it's going to start using 30 of the furnaces, which is fine. It has room to do that, it's allowed to. If now my demand for copper increases further, so let's say the demand for copper jumps up to 10, pretty quickly it cycles, and now as opposed to meeting demand exactly, it is meeting demand by an approximate ratio. So it, it lights up enough furnaces to meet its calculated ratio for this, and so it will keep production running on both lines, but say your demand for for steel, sorry, for iron is beyond this actual count, your production may go down a little bit because it's allowing the copper to be produced here. All right, so if we now reduce our demand on iron to say, actually, let's do this. Let's set them equal. You can see what that does. So now we're demanding more than this array can output, and so it just balances. We've got half of it producing copper, half of it producing iron, and all works fine. The same idea will continue up to whatever demand level you set this at. Although if you're really demanding that much out of the array, you should expand it because it's gonna kind of starve your factory. So now if all of a sudden my demand for iron dies off completely, the array will switch over to copper entirely here. And now when my demand for copper dies off as well, we can scale this back and see pretty quickly it will start responding. The response speed is basically the cycle time for creating one copper plate or one iron plate. So as we scale this down, with it being nighttime, you can actually kind of see the various combinator circuits getting triggered through all this and how they light up. But now we turn it back off and it will die out. So everything in this is belt driven right now. Primary reason for that is it's kind of a worst case scenario. If you would drive this off a logistics system with logistics robots, you could save some space on this design, but I wanted to use the belt, so it's kind of a worst case. All right, so let's see. This design is kind of based on some other designs for smart furnaces that I've seen. This one is a little bit more controllable for the way I'm building this world with the kind of lean manufacturing concept. So, I mean, I've seen other smart furnace designs from guys like Negative Root, Mizuna, Hypnobunny, those kind of guys. This one's actually inspired a little bit by Negative Root's design, but from what I can tell, his design was produced before combinators were in the game. I'm fairly new to Factorio, so I don't know when all the things were added. So this one fits more with what I'm trying to do with my factory, in that it will meet demand exactly, not do anything if there's no demand, and then try to balance demand when there is an excessive demand for products. And that's the gist of it. I guess as far as the circuits go, these are the control circuits for the overall percent calculations for figuring out the ratios for production, which are then sent through the circuit network to the entire array. Each lane of furnaces has an additional circuit which determines when it turns on if it is in load balancing mode, and it reaches load balancing mode when the entire demand exceeds what it can produce. So in this case, I have it turning on an entire line for each 10%. There's 10 lanes right now. This could be adjusted if you expand this direction. If you expand up, that works, but you've got to also make sure you're feeding enough in. Since the lane is split for these, you've got to make sure you've got enough product flowing into the array. The additional circuits here, which are tileable, these control the individual furnace and decide whether it is working in exact demand mode or balanced demand mode. And so if it's working in exact demand mode, it will fire up only when, like in this case, if we want 2 steel or 2 iron, it will only fire up these 2. But if we are working in balanced demand mode and you've got 10% of the system being allocated to iron, it will fire up these 4 furnaces. If you've got 20% of the system allocated to iron, it will fire up these 4, and the rest will be copper. So that is pretty much how it works. I will eventually try to get the blueprints for this put up here. I don't have, like I said, I'm new to this. I don't have the mod, I think it is, that allows me to get the blueprint string out of this, so that will be upcoming. And in my next video, I will show you the next level of smart furnace, the steel and stone non-deadlocking smart furnace. So that's all I've got for now.